Hello students, welcome to my YouTube channel. In this video, we are going to solve a question involving the Ostwald process described through these reactions. The amount of nitric acid is given in tons and we are supposed to find the mass of ammonia in grams needed to produce 4.89 tons of nitric acid.
Let's suppose we have X moles of ammonia that give an actual yield of 4.89 tons of nitric acid. I am calling 4.89 tons of nitric acid the actual yield because this is the amount that should be produced during the process. In step 1, theoretically, it would yield X moles of nitrogen monoxide. We can calculate the theoretical yield of NO by multiplying X moles of ammonia with the mole ratio between ammonia and NO. Ensure to place the coefficient of NO in the numerator and the coefficient of ammonia in the denominator as we are finding moles of NO produced from ammonia. We need the actual yield as the percentage yield is not 100%. We assumed an 80.0% yield in each step. We can calculate the actual yield of NO using this formula. The theoretical yield is dividing here, so it will multiply on the other side, and 100 is multiplying here, it will divide on the other side. I can rearrange the formula like this as well. For an 80.0% yield, this formula will be this, as there are three significant figures in the numerator and an infinite number of significant figures in the denominator. As 100 here is an exact number, there should be three significant figures in the answer. Remember that constants and other exact numbers do not affect the number of significant figures in a calculation as they have infinite number of significant figures. As the percentage yield is 80.0%, for each step we can convert the theoretical yield into the actual yield for each step by multiplying it with a factor of 0.800. So the actual yield of NO is 0.800 times X. In step 2, we can find the theoretical yield of NO2 using the actual yield of NO produced. For that, we will multiply 0.800x with the mole ratio between NO and NO2. Make sure to place the coefficient of NO2 in the numerator and the coefficient of NO in the denominator, as we are finding moles of NO2 produced from NO. Please note that mole ratios are exact quantities determined theoretically and are not measured with instruments. And we know that constants and other exact numbers do not affect the number of significant figures in a calculation. Then we can convert its theoretical yield into its actual yield using this formula. There should be three significant figures as both numbers multiplying have three significant figures. In step 3, we can find the theoretical yield of nitric acid using the actual yield of NO2 produced. For that, we will multiply 0.640x with the mole ratio between NO2 and nitric acid. The answer has three significant figures, as the mole ratio does not affect significant figures. Then we can convert its theoretical yield into its actual yield using this formula. There should be three significant figures as both numbers multiplying have three significant figures. Let's call this equation 1. To find the actual yield of nitric acid in moles, convert its actual yield in tons to grams. We will use these given relations for that. Focus on this part and the first relation first. To convert tons to pounds, use the relation between tons and pounds as a ratio. The pounds part should be in the numerator and the tons part in the denominator because we are converting tons to pounds. Tons cancel ton and we have the quantity in pounds now. To convert these pounds to grams, we will use this second relation as a ratio. The grams part should be in the numerator and the pounds part in the denominator because we are converting pounds to grams. Pounds cancel pounds, and we have the answer in grams. The answer should have three significant figures because the relation used are exact numbers and do not affect significant figures, and 4.89 has three significant figures. I have underlined significant figures, but I'm not rounding yet because we need that to get the correct final answer. Now we find the actual yield of nitric acid in moles using this formula. The molar mass of nitric acid is 63.01 grams per mole. As two quantities are dividing and the minimum number of significant figures is 3, so the answer will have three significant figures. Let's call this equation 2. Comparing equation 1 and 2, we can write 0.256x equals 70,404.82463. 0.256 is multiplying on this side, so it will divide on the other side. The value of x is this, and it has three significant figures as both the numerator and denominator have three significant figures. We know that x represents moles of ammonia used. We can find mass of ammonia used from this. The molar mass of ammonia is 17.031 grams per mole. Substituting the values, we arrive at the final answer, which has three significant figures, considering that one of the multiplying numbers has four significant figures and the other has three significant figures. Therefore, the minimum number of significant figures in these two multiplying numbers is 3. We can round our answer to three significant figures to report it with the correct number of significant figures. You can use this method to solve similar questions as well. I hope you understand the question. If you have any questions, feel free to ask in the comment section. Don't forget to like and subscribe